Uh, Good afternoon, students. This is the first class of the machine learning. So today we have to discuss the introductory part of the machine learnings. What is machine learning and how that machine learning model has to be designed. That we have to discuss first. So this is actually the scenario of machine learning and AI. That is the AI, that machine learning is nothing but a part of the artificial intelligence, and deep learning is another subset of the machine learnings, that is some advanced machine learnings with some advanced algorithms and advanced neural net. And another part is the data science is the part. Data science is it is having some common part with the artificial intelligence, and some other parts are there, that is the data mining part are there. So first we have to discuss about the machine learning of this class. Now what is the machine learning? That machine learning is, what is written here, is one of the most popular technology among all data scientists and machine learning enthusiasts. It is the most effective artificial intelligence technology that helps to create automated learning systems to take future decisions without being constantly programmed. That it means that it is not like a traditional programming approach. It is the approach that data has to be trained. First data has to be pre-processed, then data has to be trained, and once that data has to be trained, that training data can be applied for the new set of data, that is for the testing set of data, and to get the analytical interpretations and conclusions about the data. That means that we have to extract some knowledge about the data. It is nothing but a knowledge discoveries from the training set of data. And training set of data can be applied, if it is properly trained, then training set of data can be applied properly to the new set of data for the interpretations using the past history of the previous data. It can be considered an algorithm that automatically constructs various computer software using past experience and training data. But I told earlier that the past record is the most useful in that particular case. We have to collect the data from different sources with the different formats, and that data, multiple sources data has to be acquired first with the data acquisition techniques, and that data has to be transferred into a common format using some software, using some electronics device, and that data has to be used for the modeling of machine learning algorithms. These are all the machine learning software. That TensorFlow, that is definitely that it can be used in the Anaconda software. TensorFlow is one of the component of this Anaconda open source software. Another is Soumen is there, Apache Spark MLib is there, H20, RapidMiner, Weka, Keras, and there are some other components are there in the open source Anaconda software. That is Jupyter notebooks are also there, which is very useful writing the programs in Python and using the Python labs also, using the Python libraries also. So these are all the machine learning software that can be shown in the lab classes, how to use this software and how to install this one. This is the machine learning Venn diagrams. So first you see that the superset, that is the AI for the artificial intelligence, that is the knowledge base. So knowledge base, what is knowledge base? That is the knowledge how we have to acquire the knowledge. So there are so many components of the knowledge base. First we have to call data virtualizations, then data visualizations, then knowledge discovery, then knowledge graph. So there are so many that we have to extract the knowledge with the huge set of data, that we have to discover the knowledge. That it is called one kind of data mining, I can say. So this is the AI. AI is mainly to be used for the discovery of the knowledge from the past record history. Then next set is that machine learning. Machine learning is actually the modeling, that how to model these algorithms. There are so many number of algorithms are there in the machine learnings, and according to the desired, according to the purpose of the analysis, of data analysis, that model has to be used, and we have to use suitable machine learning model whatever be the learning procedure, it may be the supervised learning, it may be unsupervised learning, it may be the reinforcement learning. So according to the data format, according to the purpose, we have to choose the specific model of the machine learning for the data interpretations. Then is a representation learning, that is shallow autoencoders. Representation learning means the how to represent the data after using the data model in the machine learnings, and how to represent the data, how to represent the result of the data. And another, now next part is the deep learning. Deep learning is some advanced learning algorithms of the machine learnings that we have to use some deep neural net. Deep neural net that we will come whenever that particular topics will come. That deep neural net is something to be used in the complex engineering problem. That it is the another part of the machine learning algorithms, and that has to be discussed in the classes when we will arrive in this topic. Now this is the whole architecture of the machine learning. That is the first data acquisition. Now how to acquire the data? That data means that is a soft flow data. Soft flow data from the machine tools. We have to acquire the data. How to acquire the data? We have to use the various sensors like RFID tags, like RFID readers, accelerometer, also dynamometers, smart sensors. There are so many devices are there where we have to acquire the data from the soft floor. And that data, after acquisition of the data, we have to go for the data pre-processing. Data pre-processing I will discuss later. The data pre-processing means there are so many steps of the data pre-processing. That is, the first step is that the data, whatever we are collecting from the soft floor, from the multiple number of machine tools, that it is in different format. Okay, so that format has to be transferred into a common format, and normally that particular files we have to say about the CSV file, what is called that comma separated variables, that the full name of this particular file format. And after pre-processing of the data, that we have to go for the modeling. That means which model I have to use. We have to check first whether we have to use the supervised learning model or unsupervised learning model or semi-supervised learning models that we have to use for that. And after model engineering, that we have to execute that particular programs using those softwares, what I have told earlier, that Jupyter Notebook, Spider, TensorFlow. So those softwares we have to use for the executions of your programs. And we have to import some libraries of the Python, just like NumPy libraries, Panda libraries, Matplotlib libraries. There are some important libraries are there which has to be imported from this software. Then after that there will be the deployment. So deployment means that that whatever that you have executed, that has to be particularly imposed in your software, which can be actually to be used by many number of users. Even some persons, some programming persons, or some layman also, they can use it at the time of whenever that your program is ready with your training set of data. So this is called the deployment. So these are the actual machine learning architecture, that is from the beginning and how to get the result, and finally how to deploy it. Now this is the how machine learning does work. That we know that traditional programming, say for example C programming or Java programming, what exactly we can do? That we first have to input some data. That data input can be in your programs, or can be that data can be input into your interactive mode. And then we have to use some programs to be written in some high level language like C language or Java language, and after that we will get the output. Okay. Now after that we have to, that whatever output that we have to obtain using this program and data input, that we have to verify it. But in case of machine learning, it is something different. That different is that data is always there. It is a huge set of data. It is not a few set of data. It is actually huge set of heterogeneous data from multiple sources. And after that output, why I am giving the output as an input here, that output means that whatever the output that we have achieved from the training data set. That output we have to consider, and that output has to be used for testing the new set of data and to get the result of the new data set. So here that something is different. Here that input as data input and program is there, and ultimately we are getting the output. But here in the machine learning, whenever we will go for the machine learning, that we have to input some data from multiple number of sources, and then output whatever output that we have achieved from the training set of data, and ultimately that program has to be run and to get the result. So this is the actually what is the difference between the machine learning programs and the traditional programmings. Now this is the one of the first step of the machine learning, that data preprocessing, that has to be done in a proper way. That data preprocessing, so I told you that whatever data we have acquired from the shop floor or from some machine tools or from some manufacturing tools, that data has to be first acquired using some electronic devices or using some different type of sensors. What I told, that RFID tags are there, RFID readers are there, accelerometer is there, dynamometer is there, some smart sensors, some intelligent smart sensors also there. So these are the things to be required to acquire the data from the manufacturing environment or manufacturing tools. Okay. Now not only that after collecting the data we have to use some IoT. Some IoT software is there. That IoT software has to be used to send either for the execution to the standalone machine or for execution through the cloud. That IoT device has to be used. And if we use the cloud server, then what we have to do, that whatever the data we have formatted in a common file format, that has to be converted into a HTML format. And for that purpose, that web server is actually required, and that data with the HTML tag has to be sent to the cloud for the executions of the data, where all the programs are there, all the algorithms are there, and we have to use some algorithms and to execute the programs and to get the result. So that we have to discuss elaborately in some other classes whenever we'll go in deep of this subject. So here we have written data preprocessing is a process of preparing the raw data and making it suitable for a machine learning model. Okay, it is the first and crucial step while creating a machine learning model. So before using the machine learning model, before discover the machine learning model, or before implementing the machine learning model, we have to preprocess the data. Why? Because we have to collect the data from different sources. Okay. That data format will be something different. Sometimes data can be in a text format, sometimes can be in an audio format, sometimes can be in a video format, sometimes can be in an image format. So that we have to collect the data from multiple number of sources and to then transfer the data into a common format, maybe in CSV file, comma separated variables, and then we have to process the data before using some machine learning model. Now next is that when creating a machine learning project, it is not always the case that we come across the clean and formatted data. So whenever we are collecting the raw data from different machine tools or different shop floor data, what happens that some data may be missing, some raw data may be missing. So we have to handle that missing data. There may be some noise of data, there may be some outliers of data. So everything that we have to actually correct it, we have to modify it in a proper way. And then we have to, this data in a common format we have to send for the executions. And while doing any operation with data, it is mandatory to clean it and put it in a formatted way. So that what I told you. So for this we use data preprocessing task. So data preprocessing task is very important because directly collected data from the shop floor, it is not at all ready for the executions using machine learning model. Now why do we need data preprocessing? Real world data generally contains noises. I told you there are so many noises of the data. Okay, noises of the data means what? That maybe the repetitions of the data, maybe replications of the data, maybe some irrelevant data. Whenever we are collecting the data through the sensors or from any device, from the manufacturing tools, that some noise always will come, because there may be some replica of the data. We may collect some irrelevant data which is not at all required for our analysis. So it contains noises, missing values. Always there may be some missing values due to some reason, some unavoidable circumstances. We can miss some data, and maybe in an unusable format which cannot be directly used for machine learning purpose. That is the unusable format. That means unusual format, because we have to collect the data in the different formats. Maybe in the text file, maybe in some other files, maybe in some image files. So that those type of format is not at all usable whenever we are creating some model for the applications. Okay, so we have to transfer it in a common format. Data preprocessing is required task for cleaning the data. Data cleaning, that means to cleaning the noise, to cleaning the outliers, all those things, to clean the missing data. That means it is called a data filtering in some other sense, and making it suitable for a machine learning model, which also increases the accuracy and efficiency of the machine learning model. So before using some machine learning model or machine learning algorithms, we have to check our data and to go for the preprocessings to make the relevant data in a specific format. So these are the steps of the data preprocessings. So first step is the getting the data set. First to acquire the data set, because data is the raw data that I am saying about the raw data. That is the most important. Okay, using some different type of sensors, maybe RFID tags, maybe RFID readers, or accelerometer or dynamometer, whatever. Maybe some other cameras. Importing libraries, whatever the Python libraries that we have to first import it. Say NumPy libraries are there, Panda libraries are there, Matplotlib libraries are there. So there are so many libraries. That library is required. So we have to import this. Importing data set, whatever data set we have got it, that data has to be imported into a common format. Finding missing data, whatever the data is missing at the time of data acquisitions, that we have to check up, and we have to that missing data has to be filled up with some procedure. Encoding categorical data, we have to encode the categorical data. That means we have to distinguish which one is categorical, which one is non-categorical data. Splitting data set into training and test set. Now we have got say 1000 sets of data. So normally what we can do, 70% data is for the training set, and remaining 30% data will be used for the testing set. So with the 70% of the data set that we have to go for the training using machine learning model, and whatever the results we got, that particular training data set, whatever the result we got, that particular result that we have to apply for the testing data set, and then we have to verify it, whatever we have applied for the testing data set, whether what is the accuracy of the result. It may be 90% or it may be 98% or 99%. We have to check the accuracy of the result. If the accuracy is not good, then what we have to do? Then we can conclude, then we can interpret whatever the training that we have done so far, it is not enough, it is not sufficient. So we have to go for train the data again with some other set of data, or using some other algorithms. Maybe the classification algorithms, maybe the clustering algorithms, maybe the association algorithms. So whatever be. Now that the feature scaling. Feature scaling means that you have to scale the data, because you know that, say, for the age of a person, height of the persons, weight of the persons, say speed, say power output of the particular car, torque output of the particular car, you will say that there are different types of units are there. Say height, actually it has to be used in either in inches or centimeter. Weight has to be used either in grams or maybe in pounds somewhere, or age, actually the unit that we are using it as a years, month or days, like that. So that the unit is something different. So we have to standardize the data, or we have to normalize the data. That means that all the data, all the different set of data, whatever to be used at the time of machine learning modeling, that has to be done in a common unit or with no unit. So for that purpose, that we have to either standardize the data or we have to normalize the data. Whatever standardization, what is standardization, what is normalization, that we will discuss in the next slide. Now first get the data set. That I told you that data set has to be, first we have to acquire the data from the different sources, different multiple sources. To create a machine learning model, the first thing that we require is a data set. As a machine learning model, completely works on data. The collected data set for a particular problem in a proper format is known as data set. Data set may be different formats for different purposes that I told you earlier. It will be in different formats, sometimes in a text file, sometimes in CSV file, sometimes in Excel file, sometimes maybe in image file, sometimes maybe in audio, sometimes maybe in video, like that. To use the dataset in our code, we usually put into a CSV file. That CSV, I told you that file is normally used for the Python coding. And whatever software I told you, that Jupyter Notebook, Jupyter Lab, Spider, and that it is nothing but a Python, and we have to use that CSV file. However, sometimes we may also need to use an HTML or XLS file. HTML file also sometimes we need it, because if we go through the cloud, then through the web server, that we have to convert the data into a HTML format. That we have to use the web server in between cloud and in our workstations. CSV stands for the common separated values. So this is the full form of this particular name. It is a file format which allows us to save the tabular data such as spreadsheets. It is similar, very similar to spreadsheets. It is useful for used data set and can use this data set in programs. We can also create our data set by gathering data using the various API. API stands for Application Programming Interface with Python, and put that data into a CSV file. So that I already told you. Now what are the main libraries that you have to import before execution of your programs? So these are the libraries. It is called the Python libraries. In order to perform data preprocessing using Python, we need to import some predefined Python libraries. Those libraries are used to perform some specific jobs. Definitely that you will see what that those particular libraries, what is the function of those libraries. These are three specific libraries that we will use for data preprocessing. This is the first one. This is a NumPy. NumPy Python library used for including any type of mathematical operation in the code. Any type of mathematical operation, say sine. If we use that sine, actually say sine x, cos x, tan x, this type of sine function, cos function, tan function, then we can use 9. If we handle some matrix manipulations, maybe multiplications, maybe additions, or maybe inverse of the matrix, so then we can use that NumPy's particular libraries. It is a fundamental package for scientific calculation in Python. It also supports to add large multi-dimensional arrays. What I told you, we can use matrix with two-dimensional matrix with multi-dimensional also. Multi arrays and matrices. In Python, we can import it as. So how we have to import it? That is actually, you will learn it in the laboratories. So we are not going to discuss it. That you have to learn it in the libraries how to actually import it. Now next one is the matplotlib. This is the second library, and matplotlib is which is a Python 2D plotting libraries. Whenever it is called a knowledge graph, whenever we are representing the knowledge from the training data set or testing data set, that knowledge has to be represented in such a way that any layman can understand. Because I don't know what is Python, what is some other language, what the machine learning model we are using. I am not a person in the computer science. So how to understand that what you have done? So we have to represent our knowledge in such a way that any people can understand. So that presentation, it may be something different. It may be represented in the knowledge graph. It may be represented in some other diagrams. It may be represented in some text format. It may be represented in video format with some animations. So here in the matplotlib, it is normally used for the knowledge representations in a graphical way. Okay. So we need to import a sub-library that is called pyplot. Okay, the library is used to plot any type of charts, Python for the code. Maybe pie chart, maybe the bar chart, maybe the histogram, maybe the multiple bar chart, like that. Now the most important libraries is the pandas. The last library is the pandas library, which is one of the most famous Python libraries. Pandas has a higher level interface. Why it is higher level interface? It allows you to store, manipulate tabular data as a 2D data structure. So whatever be the data, your dimension of the data, that can be represented in the 2D format. Pandas provide a rich feature set on data frame. For example, data alignment, data statistics, slicing, grouping, merging. Slicing, grouping, that it is a very common term of data warehouse. Actually, that slicing, that means to reduce the dimension of the data. Say 3-dimensional data can be actually represented in 2-dimensional form or in a 1-dimensional form using the slicing, grouping, like that. Slicing, dicing, grouping. So these are the very common terms in the data warehouse. Merging, concatenating data, etc. So we have to concatenating data means one data has to be data from one source to be concatenated with the data of other source. Now this is the way that how to import those data sets using either Spider or Jupyter Notebooks or Jupyter Lab or using TensorFlow, like that. That you can understand in the laboratory classes. So we are not going to discuss about all those things, only we are going for the theoretical concept. These are all the things that you can see it in the lab. Whenever you will open that Jupyter Notebook or Spider of the Anaconda software. Now handling missing data. So how handling the missing data? So suppose that some data are missing. In some rows, whatever data has been collected. So what we can do, what is the easiest way? That we have to delete this particular row. So we are having a huge data set, say millions of data set, thousands of data. The data size is more than 1,000, more than say 10,000, like that. So one row, if we miss it, it's not a big problem for that. So this is the easiest way that we have to miss. We have to remove the entire column or we have to remove the entire row. But there is some other way, because which data is missing. In some other rows that data are there, data are available. So what we can do in the missing data, particularly in this cell, we have to take the median or we have to take the mean of those data which are available in this particular column. So those things has to be handled in this. Either you have to remove it, the full row or full column, or you have to take some mean or median or like that. Those things, either mean. Normally we are considering the arithmetic mean. The calculating the mean is what I told you. We will calculate the mean of the column or row which contains any missing value, and we will put it on place of missing value. This strategy is useful for the features which have numerical data such as age, salary, year, etc. Here we use this approach. So this can be very useful whenever we are dealing with the numerical data. Now this is the encoding. That we can use some dummy variables. Dummy variables means that the dummy variables are those variables which have values either 0 or 1. 1 means availability of the data in a particular column, and rest variables become 0. That means the data is not available in this particular column. So we have to use some dummy variables from where we can understand that which data is missing, which data is available, or which data we have to go for the modifications. So this is that way that this is the entire set of data. First of all, the training set. Next one is the validation set. Next one is the test set. Normally we are not using the validation set, but validation set is also very important, because I told you whenever we are considering the large set of data, normally we are using 60 to 70% of data for the training data set, and validation means that we have to validate the data. How it has to be validated? Whatever the result we got, that we have to validate. Okay. So for this purpose, we are having another set of data from the source data. It may be 10%, it may be say 5% like that. And then after validation, after being satisfied with the result of the training, then only we are going to test a new set of data. We can apply in some other data. So these are the three parts of the data. One is the training set, then validation set, and it is the testing set. Feature scaling. Feature scaling is the final step of data preprocessing in machine learning. It is a technique to standardize the independent variables of the data set. I told you that whatever data you are collecting from the machine tools or from the soft floor, that all the data are not having the same unit. Okay, so that unit, so we have to remove the unit to train the data simultaneously. So it is a technique to standardize the independent variables of the data set in a specific range. The feature scaling will put our variables in the same range and the same scale that no any variable dominate the other variables. Then how can be done? Just it is for the lab purposes. I am not going to discuss all those things. Look at it is called a standardization. Suppose x is a variable. X is having a unit. Say for we are assuming that a unit is centimeter. So what we can do? X minus mean divided by a. What is a? A is the standard deviation. So whenever I have to scale, I have to standardize by this way, then there will be no unit. So that we have to make all the data to be unit free. So this is the way. It is called the standardization. And what is normalization? Normalization also that we can do it whenever it is required. That is x minus mean of x divided by range of data. Maximum of x and minimum of x, where x is the independent variable or independent features of the whole data set. So by this way that we have to scale the data in such a way that no unit has to be used whenever that we are going to use the machine learning model. Okay. So now what happens if we scale the data? Then what happens that no data item can dominate other data items. So this is the way. So this is the way for the up to pre-processing of the data. Then after that we have to use some machine learning algorithms or machine learning model for according to our purpose, according to our analysis. It may be supervised, it may be unsupervised, it may be semi-supervised, it may be reinforcement. So whatever be that we have to do it. So up to this slide that I can finish my lecture. Now that I will continue in the next class. Thank you.